Hey, welcome back to Math with Patrick. Today's August 4th, and we're solving problem number 216 from the Daily Epsilon calendar. And it should be, or the answer should be for today, because that matches today's date. So let's see if it works out the way it's supposed to. So find the radius of the circle inscribed inside a right triangle. So let me draw a little picture. So here is our right triangle. Then I will inscribe a circle in it. That just means like draw a circle inside the triangle where it like perfectly touches the sides of the triangle, just like that. And the shorter leg is 10 and the hypotenuse is 26. The legs of a right triangle are just like the shorter sides, the ones next to the right angle in the corner. And the hypotenuse is the longest one. And we need to find the radius of this circle. So like we could maybe draw the center of the circle, and any of these distances are going to be the radius. And I could even draw one like right over here, but I'm trying to draw radii that like connect to other parts of the diagram. So like to me, it would make sense to draw all of these ones, just because like they kind of intersect the sides of the triangle. So I think we should probably use the Pythagorean theorem first to find the missing side. So we could do like 26 squared minus 10 squared equals like b squared to get this side. Though this one is proportional to a Pythagorean triple that I just already know. The 5, 12, 13 right triangle is a pretty common Pythagorean right triangle. And this one's proportional to it because if you multiply all the sides by 2, we're going to get 10, 24, and then 26. So for that reason, I do know that this number is 24 without actually needing to go through all those calculations. I think we'd get like 676 out of that one. We could subtract off the 100 for the 10 squared. That does get us 576, and I'm pretty sure this is 24 squared, just if you wanted those quick calculations. All right. So somehow this is enough information to figure out what the radius is. This in the corner kind of looks like a square to me. So I could name this R and that R. I think that makes sense because this is a right angle, that's a right angle. These are definitely the same length because they're both radii. And then if these are both 90 degrees, then so are these. And then, okay, since everything's parallel here, for sure, I can call this a square. How do I do this one? I'm not quite sure. Maybe I could figure out something. Oh, there it is. I could figure out something about like this length right here. And kind of just by symmetry, that should be the same length as this part. We could, I don't know, maybe draw a dotted line in here. And you can kind of tell that these two triangles are just reflections of each other. And the same thing is happening over here, where we have two longer triangles, and these ones also are just reflections of each other. And let's see. So let's try to figure out some stuff about these sides. Like, for example, we could do like G plus R equals 10. I'm doing G for green right here. We could also do like B plus R equals 24. I'm doing B for blue. And then I know that G plus B is 26. And I'm just getting that from my hypotenuse because the two sides added up equal the hypotenuse. So let's take these equations and I'm going to pile the left-hand side of these equations over here and the right-hand side over here. So since G plus R is 10, I could put G plus R here and 10 here. And then I'm going to add B plus R to the left side, and I'm going to balance it out by adding a 24 to the right side. So I know that this equation is true because I'm just pulling from information from previous equations. So that tells me that G plus B plus 2R is equal to 34. But then I do know that G plus B is 26. So I could replace this with 26. This shows me that 2R is the difference between 34 and 26. That is the number 8. So 2R is 8, and that must mean that R is 4. Cool. Well, there it is. That's the radius. So all of these R's I could replace with 4's. So that does mean that this length is 6. That's also a 6. This one happens to be a 20. That happens to be a 20. So cool. Just filling out more information about the diagram. But ultimately, the radius is 4, and that's how I'd solve it. So hope you enjoyed this solution, and I'll see you in the next video. Bye.